Good morning, and thank you all for joining us. I'm John Calloway, I'm the Delta lead scientist, and I hope you have your coffee and tea ready for what I'm sure is going to be a very informative and interesting discussion this morning. As you know, this is the third of a four-part discussion series focusing on building an effective, forward-looking Delta science enterprise in the face of climate change and other rapid changes. This series is designed to bring in broad input across the Delta community, and it will inform the Science Needs Assessment workshop that has been rescheduled to October. So before we jump into the discussion, a few housekeeping details for the morning. If we welcome your participation in the discussion, but please mute your computer so that there's no interference or background noise. Turn off your video camera unless you're asking a question or providing comments. That will maximize the bandwidth for everyone. If you're on the phone, you can use *6 to mute or unmute yourself. And you should be aware that we are recording this discussion so that it will be available to a broader audience. So to start things off this morning, Steve Brandt from the Delta Independent Science Board will give us an overview of the ISB's call for forward-looking science and discuss the motivation for holding the Science Needs Assessment workshop and these workshop discussions, and he'll give us an overview of the previous two discussions that have occurred. So but the primary focus of today's session is to the conversation with our three panelists. The panelists will be discussing the science that's needed to support forward-looking issues in the Delta, and we couldn't have a better group for this. We have Stephanie Fong from the Interagency Ecological Program and California Department of Fish and Wildlife, Louise Conrad from the Delta Stewardship Council, and Mike Chotkowski from the USGS. As in the previous discussions, we'll be posing questions throughout the morning via Mentimeter, and I'll provide some instructions on Mentimeter in just a bit. We do have about 15 minutes at the end of the discussion for Q&A, so to start thinking now about questions you'd like to include in the discussion. As is indicated on the slide, you can ask a question orally by using the raise hand function on MS Teams to indicate that you have a question. You're also welcome to provide comments via the chat function, and if you can't find the chat function, feel free to email your questions to disb@deltacouncil.ca.gov. So with that, I'll turn it over to Steve Brandt for his introduction.
Thanks, John, and welcome everyone, and thanks for attending today's discussion. I'm going to give you a very brief overview of sort of what started this effort, where we are in this process, and where we plan to go. This effort largely started by a letter that the Delta Independent Science Board wrote to DPIC that pointed out the need perhaps to look at developing more forward-looking science in the context of the fact that the Delta is changing rapidly and is likely, those changes are likely to accelerate under things like climate change. We suggested one of the main things that ought to be done was to develop a comprehensive science needs assessment, sort of looking at the fundamental system-wide scientific and management challenges facing the Delta, and that we should use that science needs assessment to explore future Delta conditions and fundamental driving forces, and also to look at what science is needed to forecast or predict how the Delta might change under these conditions. So that's what we're talking about today, and that's part of this effort. In parallel, Delta Science Board has also developed a discussion paper on this topic and ran a couple of scientific panels to explore some of the preemptive scientific needs. And we summarized that in a recent DPIC meeting, as well as a DPIC memo to DPIC in April. Next slide. We have a 17-member planning team that's been working on this effort. And this is a list of the individuals involved. The next slide. As I said, this effort is really sort of co-hosted by the Delta Plan Interagency Implementation Committee and the Delta Independent Science Board, with help, of course, and input from the Delta Council and Delta Science Plan, or Delta Science Program. We developed an advanced briefing paper that outlined the rationale of where we intended the workshop to go. And we originally had scheduled the workshop for late April, but because of COVID, of course, we rescheduled it now for sometime in October. So in the interim, we decided to hold 4 discussion sessions to really dive into the 4 main questions and topics that we had intended to explore in the workshop itself. And the next slide. Our overall goals for this effort is to really identify some of the key scientific efforts that will provide answers and insights for likely management questions in the long term. Are we prepared? Is the science ready to look at really those comprehensive, challenging questions that the Delta currently faces, but are likely to be even intensified under a changing Delta in the future? And once we've identified those questions, we need to ask the question to discuss how to organize the science enterprise to address some of these more complex and changing problems. The next slide. So the 4 discussion topics that we are talking about, again, which are taken from the main 4 topics that we were going to address in the original workshop, was first, what do we need to know about, or what do we know about projected climate change impacts for the Delta? What is going to change in the Delta? The second question is, given that, what kind of questions will that raise for management decisions? What do managers need to know? What kind of science do they need to know in order to address those challenges? The third question is, what science needs to be done to give management those answers? That's the topic of today. And then the next question after that is that, given that we know what the science needs to be done, are we prepared with our science governance, funding, and integration in order to be able to do that kind of science? So very simply, what problems do we expect? What is that going to mean for management? Therefore, what kind of science will management need to make those decisions? And finally, how can we better, or how can we improve the science organization or integration to address those science questions? The next slide. Now I'm going to give in about 1 minute what we discussed for over an hour in each of these previous presentations. The first one, given by John Calloway, was to discuss where we are with respect to expected changes in the Delta due to climate change. John identified several of the key mechanisms that are really going to affect all parts of the Delta ecosystem: increased air and water temperature, as well as changes in the timing of seasonal warming, as an example, changes in the precipitation and runoff, and perhaps the extreme events associated with those, and sea level rise. We discussed the variety of time frames. Some of those changes are occurring right now. Some of those changes will be amplified in the future. So really, it's a range of time frames we're looking at from now until a long time into the future. John pointed out the need to connect other drivers to climate change, changes in land use, invasive species and contaminants, and human use and human responses. They all impact the Delta as well. They're all likely to change, and clearly they all have interrelationships to projected changes in the climate. And the last point is that perhaps we should focus on impacts that we particularly know are going to happen with respect to things like water quality, habitat, species, and perhaps some of the human impacts. We had a lot of participant input to our Mentimeter questions on this, and they range for asking questions about how will external water demand change, some of the biological questions, for example, on the onset and duration of seasonal warming, how will that affect the biology and interactions? Invasive species, of course, will have a connection to climate change. Will there be tipping points that are associated with extreme events? And in terms of human responses, what about the population and land use changes? Those are just a handful of many, many comments we've received on our participant support, input, I mean. The next slide was to address some of the management questions and what do we need to think about in terms of management in this context. And clearly, some of the overarching principles brought up by our three panelists were that we need to have community buy-in and support, that one of the things we need to make sure is that just to use science to guide prioritization of funds and perhaps to guide prioritization of management. Collaboratively develop overarching set of strategic management questions to guide Delta science. There's discussion about uncertainties and that we need to understand those uncertainties and what the range of those uncertainties are. And then finally, and perhaps a major focus on flow to create a scientifically rigorous strategy for Delta conservation. The next slide, we asked participants again, and this again is a very brief summary. Participants, their comments focused on a variety of things, including the need for synthesis, both in the monitoring information and the various kinds of efforts we've had in terms of implementing projects, successes and failures. There was a lot of suggestions about the need for forecasting and prediction tools as part of the management set of priority science. Recognizing also that there's a synergistic effects of the various changes going on in the Delta. It's not just climate alone, it's the things of climate effects, and conversely, the rates of changes in other driving forces associated with climate change. Prioritization with a list of trade-offs and risks. Of course, the need for social science perspective and integration. And then finally, a consideration of experiments derived from management questions, i.e. adaptive management. So that's in very briefly. The next slide, I'll turn back over to John, who will introduce today's topic, and we'll go from there. So,
great. Thank you very much, Steve. So actually, before we get into our panelists, we want to ask you just a few introductory Mentimeter questions. So if you have your smartphone or open a separate window on your computer and go to menti.com, www.menti.com, and you can enter the code 464250. So that's menti.com on your phone, and the code is 464250. So Edmund, can you, yeah, perfect. So there's our first question for you is just to get some background information. So if you could tell us what kind of organization that you work for, state, federal, local, university, and provide some input there. We'll see who we have in the audience. And it looked like we have, I was just looking at the participant list, we have about 80 people participating on the call. So we have great participation again. So we're really happy to see that. Looks like mostly state agencies, but we'll see. We'll wait just another minute, a few more seconds to get your inputs on this. Okay, looks like we're still mostly state, but some federal and other organizations. So actually, let's go to our second question. And the second question is, what management themes based off of the Delta Plan best reflect your work or background? And those are water supply, flood risk, water quality, non-native species, native species, habitat management or restoration, and land use or Delta as an evolving place. So actually we're getting a wide range there. It's good to see there's such a mix. It looks like I can barely read the cat there, but it looks like flood risk is the lowest, but a pretty even distribution across all of those. Okay, so we will have some more questions where you'll have an opportunity to give not just multiple choice, but give us some more input on some of the topics that we're going to be discussing. Thank you very much for your input, and I think we'll move on to our panelists because that's really what we want to focus on. this morning. So we have 3 panelists. Each of them have been asked to provide a brief overview of the questions that were provided about this that are here on this slide. What science is needed to support future decisions? How is your program preparing for future changes? There's a lot to cover there, and we have limited time. So given the time constraints, I know that they won't be able to answer all of these, but we're really excited to hear your input. We couldn't really have a better panel, as I mentioned. So we'll start with Stephanie Fong. Stephanie is the program manager for the Interagency Ecological Program and is also with California Department of Fish and Wildlife. And so I will turn it over to Stephanie for her comments.
Thanks, John. I just wanted to thank you guys for inviting me to speak today, and that I'm hoping that I'm accurately representing our large consortium of agency scientists as well as managers in this discussion. But when I think about what science is needed to support future decisions, I first think about the situations that cause managers to have to make hard decisions. Like, all of our major issues are priorities. So it isn't usually a question of whether or not something is important to address. It's more whether or not these issues have ramped up to this emergency status that cause us to redirect our limited resources and how we can address them. And I think there are always emergencies that are going to be changing our focus. So in order to support those decisions that have to be made in sort of these emergency situations, we need to have a good handle on the mechanisms and relationships involved. And so mechanisms and relationships among biotic and abiotic variables, among species and communities, among species in different habitat types, across different year types, those sorts of things, seasonality, life history, life stage, those sorts of things. And if we can make significant progress understanding those types of mechanisms and relationships, we can better understand which management actions should affect which outcomes in sort of the most opportune ways, right? And in order to get to these mechanisms and relationships, I think we need a lot of these newer tools that we've been advancing, like quantitative models and machine learning, and the models are getting more and more complex, and they're able to assess a greater number of variables, but also we need to make sure that we're giving those tools the right kinds of information. So are they getting the right kinds of data at the right frequencies and locations to make those models work properly in the way that we would like them to, right? We have to also understand some of the sublethal effects and things like behavior. If we don't understand these relationships on these sublethal levels, some of our other efforts might just be wasted. We should understand things like disorientation, or the ability to track or detect right females, or things like that. And some of our more urgent needs are things like the ability to detect and count organisms in a non-lethal way and in different types of habitat. So where species of concern live, take of listed species is a pretty important thing for us to consider, and it's getting tighter and tighter every year. And we need to really understand how we can potentially monitor these communities with reduced take. And part of that would also be things like understanding how life history choices or natal origin affect organisms as well. So should I just go through all of my general comments on all 3 questions at this point? Sorry.
Yeah, you can. Yeah, you have a couple minutes left, so if you could just give us any
speed it up a little bit. Sure. So things that we've been doing to prepare our science program for the future are things like really finding new ways to use our really vast long-term monitoring data set. We're trying to provide on-the-job training and mentorship opportunities through things like our synthesis efforts and review efforts. And we've been trying to emphasize the need for things like short courses at our annual workshops. So we're really trying to build our infrastructure and put additional focus on things like science communication, sample curation, synthesis, and data stewardship, open data, right? And if there were a few things that I would like to have maybe done with others that we haven't quite gotten to yet, I would have definitely liked to combine some of our efforts with things like the Federal STAR program or with the Water Board's data science symposiums to help advance technologies and data science, to pair those together. And as far as our strategic research goals and products, our science strategy really lays out our scientific plan along with our strategic plan and our annual work plan. And just for folks that may not know, the things that IEP has identified as the priorities for our next 5 years really come down to resilience to climate change, restoring native fishes, assessing the effects of flow alteration, especially the dynamics between flow and habitat and species performance, food web and habitats for species of concern, and then a couple of unmet science needs that were identified in our science strategy are contaminants and aquatic weeds. So I don't want to take up too much time. How much time do I have left?
I think let's move on to Louise, and we'll be able to come back if you have additional thoughts on, through questions.
Sounds good. Thanks.
Okay, great. Thank you very much, Stephanie, for all that input. So Louise Conrad is the Deputy Executive Officer of Science at the Delta Stewardship Council, and I'll turn it over to Louise. And you're on mute, Louise.
I hope I'm off mute now. Thank you very much, John. And thank you to the Delta Independent Science Board and the Stewardship Council for holding this discussion. I am excited for our conversation. So I'll briefly go through the questions that we were posed. And so first, what science is needed to support future decisions? I agree with a lot of with everything Stephanie highlighted. And the way I think about it is that we really have a large spectrum of science needs that kind of spans basic data science capabilities to building predictive and integrated models. And I want to just highlight 4 items that I think all would serve the science enterprise, if we can focus on them, to become even more nimble. As with this rapidly changing environment, we need nimble management decisions, and to do that well, we need a nimble science enterprise. So on the data science aspect, I think we need to expand and advance our techniques so that we are positioned to manipulate big data quickly. We have big data in our system. We need the capacity to rapidly be able to use our large data sets. Along the lines of what I loved Stephanie's highlight of the need for a deep understanding of mechanisms. And I want to express another angle on that, which is that I think we need a really broad understanding and deep understanding of our species communities. That's really important for being able to develop robust predictive models. We already have deep knowledge about some specific species like Delta smelt or Sacramento splittail. And we need to move towards thinking about communities that range from phytoplankton to fish. And I think we also need to include humans in that community too. And we need to focus on both invasive and native species. That is critical to developing a more of an understanding of an ecosystem response to critical changes in drivers and responses to management. And so I will also want to highlight the need for us to have a sharp eye out for invasive species. As our environment changes and we see rapid change, it's not just those drivers changing, it's not just temperature, it's not just salinity, it's the community itself. And we're going to see newcomers to the system. We already are seeing them. 2017, we saw the presence of alligator weed in the system. And now alligator weed is much more widespread than it was. So we need to be able to have our eye out. We need to be ready and think proactively about how we will respond for certain invasive species that are in other systems and we know are game changers for management. And then finally, I think this was highlighted in some of the previous discussions for this effort. We need a really robust understanding of the human dimension of our system. And I think about that very broadly. I think it spans the very Delta residents that are living in the system, but also the consumers of the Delta water and the footprint of the Delta throughout the state and the management of the Delta. This is a culture shift because we do and we are trying to hire more scientists with social science expertise, but it also is a shift in our culture as a science enterprise because regardless of our discipline, we need to become in the practice of being inquisitive and inclusive of considering the human response to change. So those are my thoughts on that first questions of science needs. And with the time I have left, I want to talk about how the Delta Science Program and the Stewardship Council are preparing for future changes. All of these things are really important to being able to address those science needs that I just talked about. So first, both internally and externally, we are working at the Delta Science Program to support a cohesive, vibrant, and diverse science community with respect to the scientists themselves and also the range of expertise and institutions that are engaged. Here's a few examples. So one is we are working to establish a consistent and reliable program for competitively funded science that would be available to a broad community. And this is a critical recommendation, as you may know, of the DPIC Science Funding Initiative. We feel, and I know that we're not alone in this, this is one of the reasons that the specifically competitive process is important, is that it is grounded in a peer review process so that we are making funding decisions that are unbiased and robust, and that it's transparent, and that it can be available, like I said, to this broad community. We may not know all the people that can bring great science to bear for our community. We hope to do this in a way that engages funding partnerships with other organizations that share this goal. And then we are also implementing the Delta social science strategy. I mentioned this a little earlier, but we are working to hire scientists with social science expertise and then work with them to build this network of social scientists that would then be integrated with natural scientists. So I want to just, I know I'm running out of time, John, so I want to just make one more point that I think is important, and that is that I think one other thing that we're trying to do with the science program is really contribute to the growth and the visibility of what I'm going to call rock star synthesis scientists. It really needs to be that high profile, and I want to acknowledge that this is already going on, and a lot of the efforts within the Interagency Ecological Program, there's a growing body of scientists that really are rock star synthesis scientists. We also need to recognize them purposefully and deliberately as critical members of our community that inform our management decisions. So it's important at the science program, I think a lot about how it's important that they feel that they are part of a community. And at the science program, we have a goal of facilitating major synthesis working groups every other year that would involve scientists from the full community and include partnership with major synthesis centers like the National Center for Ecological Analysis and Synthesis. And that first effort will take place in 2021. John, would you like me to leave it there so we leave time for Mike?
Yeah, I think that would be great. I know we challenged all of you with a very short 5 minutes.
There's so much more I want to say.
You've packed in an enormous amount, so I think there'll be some great discussion. So yes, let's hear now from Mike Chotkowski. Mike is the science coordinator for the Geological Survey in the estuary and the Delta.
Yeah, and good morning, everyone. I too feel some pressure because we have only 5 minutes to make some comments here, but I think it's useful for us to do this in part because we're laying the groundwork for the dialogue that's going to happen in October. And I think I hope what the three of us are going to do is give folks some things to think about before we have that broader discussion in October. So I have a few essentially bullet points that I'd like to make by way of response to these 3 questions. And just to begin with the large question of what sorts of science should we be doing in the future. When I look into the farther future beyond the next 5 years or so, I see, number one, that we should be spending more of our resources building a better understanding of the underlying processes that contribute to the way the estuary operates and the way that the natural elements of the estuary that are the subject of a lot of the controversy here respond to changes in the natural environment and changes in management. As we know from the last 30 years of study, most of the listed species are not controlled by a single factor. They respond to multiple environmental factors, and it's important for us to understand the interplay between those various factors. And it's an effort that I believe we've somewhat underemphasized in the past. And one of the reasons why it's important for us to focus on understanding how the estuary works is that it will allow us to make better predictions about how the estuary will respond to management decisions that implicate changes in management that we haven't observed before. I think with the climate changing, we're going to be facing quite a bit of that in the future, and we should feel somewhat humble about our level of understanding at this point. Although I think we've learned a lot in the last 20 years, we still have a long way to go. So my second bullet on what's needed in the farther future is we need to develop better tools to bridge the gap between scientific findings and the management decisions that need to be made down the road. We've done, I think, in this system and in others, we've done a good job of learning things that are important to management, but I think we've got a ways to go in terms of providing that information in a form that can actually be used by managers. And I think this implicates a team effort involving everyone, from the people who are in the trenches doing the scientific research to the people who are in the trenches making management decisions. We need to work together and develop better tools to enable the findings of the scientists to be used by managers when they're making important policy decisions. My third bullet for things we need to do for the far future is that we need to coordinate better among programs and efforts. There are several represented on this call today, and there are a lot of others. As we know, there are a lot of independent efforts to conduct science in the estuary, and there actually are a lot of consortia that are working on this too. And we need to work more closely together. It'll help us to reduce duplication of effort. It'll allow us to extend ourselves a little farther in areas where no one entity has a great deal of skin in a line of research, but we all have some skin in it. And working together, possibly in the future by having a broader system of governance for how science gets done, should enable us to refine the allocation of resources, which I think is already pretty good, but again, could be a bit better in the future. So in order to move forward, and I'm speaking strictly from the perspective of my position at USGS, there are 3 or 4 things that I see us doing somewhat differently in the future, and none of these is revolutionary. These are things that we simply need to work on changing our emphasis in order to meet the challenges in front of us. The first, just to revisit my last bullet for what's needed, is we need to increase our emphasis on cooperative planning. We need to work together to make sure we're covering the bases, and that means we aren't only reacting to the needs that we see directly in front of us, but we're also working on things that we're pretty sure we're going to need down the road. Louise and Stephanie mentioned a couple of those things. I won't get back to them because, again, for time limitations, but we need to work more together. Second, in the future, I think we really need to work to increase our emphasis on modeling and forecasting because, again, as our understanding expands, the difficulty of understanding how the whole machine, our whole regional natural and management system works is going to become more difficult, and we're going to become more reliant on models and forecasts in order to make best use of what we know to make management decisions. Third, I think we need to increase our emphasis on the data platforms that we use to store and serve the needs of various parties who want to take advantage of science. As people are probably aware, but may not be fully aware, our ability to collect information about the environment has expanded very rapidly in recent years, and it's becoming increasingly difficult just to manage the amounts of data that we are generating, and we need to devote some resources to sorting out how we're going to do that, again, jointly, and how we're going to provide front ends to that information that make it easy to access. And last, and this is a USGS perspective, I think we need to invest more effort in planning across geographical systems, because we do in fact have quite a bit in common with some of the other estuarine systems around the country, and we should be availing ourselves of things that are being learned in those systems, and likewise they should learn from us. And John, I see your face appearing here, which probably means my time's up.
Yeah.
So
thank you, Mike.
I just would like to make 3 quick comments about strategic goals. The first is that this needs to be a team effort. We can't do this individually and expect the best outcome. Second, our strategic goal setting needs to reflect an understanding that the longer term goals aren't going to be reachable unless we make a commitment in the near term to working on these efforts and committing some resources to them on a consistent basis. And the third is that long-term strategy doesn't necessarily require increased funding. This isn't a plea for funding. It's a plea for cooperation and for more effort looking over the horizon. It may lead to a need for more funding, but that's really not the objective here. The objective is simply to do a better job of preparing us for the future. And John, I'll stop there.
Great. Thank you, Mike. Thank you, all of you. Those were lots of really interesting comments that I think we'll have some very good discussion. So before we move to the discussion, we have a few more questions on Mentimeter for you. So if you could pull out your smartphone again or open up another window on your computer and go to mentee.com and go to enter that code again, 464250. So the first question for you is, what are the major research gaps related to assessing and predicting rapid environmental change driven by climate change? So you've heard from our 3 panelists. If you have thoughts about any specific research gaps that you want us to be aware of, now is your chance to give us some input on that. So this may take just a minute or two to people start to get online and start typing in some answers. But as you enter your answers, we will see synthesis of existing long-term data sets. We've heard a lot about data sets and databases, clunky databases. How will climate change impact our ability to control the environment? A lack of understanding of food webs, a magnitude of change of rates of sea level rise, how invasive species respond. So we're getting lots of input now. We'll wait just another 30 seconds or so, and I encourage you to provide any thoughts here. If you don't get a chance, I would encourage you to email us and provide any input, because we are going to be compiling all of this input to help shape the workshop in October. So I see small scale habitat use. We heard a lot about community issues, understanding of how species maturation and reproduction is affected by temperature. Lots of really valuable input here. That looks great. Forecasting tools, I think we heard a lot about those. The need for forecasting as something that we really need to focus in on. Okay, well, so for time, I think we will move on to our next question. So Edmund, if you could advance the next question. So this question, we have this and one more question before we get to the discussion. So what do you see as major strategic research products for the science enterprise, such as forecast tools, technology methods, or models? And we heard a lot about this already. So if you have any specifics about what you think would be valuable here in terms of modeling, forecasting tools, the kinds of things that Mike talked about in terms of translating our science understanding into information that's usable for decisions. So we have decision tools, cloud computing infrastructure, accelerated species identification. I appreciated Stephanie's comments on non-lethal monitoring. I think that would be really valuable. Forecasting tools for flow and habitat, coordinated estuary-wide monitoring, generating data for regional models, improvements in acoustic telemetry, forecasting, process-based forecasting tools, models allowing assessment of alternative management decisions, continuing to improve our ability to use eDNA, landscape and scenario planning tools. Okay, great. So I encourage you again, if you have some thoughts here, another 20 or 30 seconds to type in, give us some input. And if you don't get a chance, do feel free to follow up with us and we will happily take your input. Integrated modeling tools for water quality and temperature. Okay, so let's move on to our last question then. And that question is the ecosystem scale for across the Bay Delta an appropriate scale for strategically researching management topics? Great. We've had a lot of discussion about scale issues, and I think what we've heard is, that's really a valuable scale. It's not necessarily the only scale. It depends on the question and the issues, but I think that ecosystem scale, it looks as though we're getting a majority there with feeling that is appropriate. Okay, well, you can keep answering that question, and we will now we'll get a chance to move into our discussion. So we have about 15 minutes left, and remember that questions can be submitted in multiple ways. If you'd like to there's the raise hand function on MS Teams. You can use that if you'd like to, and then we'll call on you and you can ask a question, or you can put a question in the chat box, or if not, you can email to disb@deltacouncil.ca.gov. So let's see, and Edmund or Cheryl, if you, I'm looking at the chat area, but if you see questions or if you see someone raising a hand that I don't see, please just feel free to help me out with that. So any questions? Anyone want to raise your hand to get things started? Or if anyone on the panel has a question for other panelists, if you'd like to, if there's something you heard on any of the panelists that you'd like to dive into.
Hey, John, it's Josh Israel.
Yes. Hi, Josh.
Hey, I had a question. I raised my hand, so.
Okay, I see. Please ask away.
Thanks. So your last Menti question sort of stimulated some thoughts on scale for me. And we're talking about the Bay Delta, it seems like in a somewhat isolated fashion. I noticed most of the management topics, the earlier Menti questions are much broader than just the Bay Delta within the Central Valley with the rivers that flow into the Bay Delta. Is the Bay Delta an appropriate scale for thinking sort of forward thinking science needs, given that climate change is happening on a much broader scale than just the Bay Delta alone?
Panelists, any panelists want to dive in and jump at that? Should we be, how much should we be pushing up into the watershed for these kinds of issues?
Yeah, Josh, I'll just throw out the opinion that it depends entirely on the question. I mean, there's some things that are really inherently watershed scale questions, and there are others that aren't. So, you know, for example, a lot of things that reclamation has to deal with are probably sub-water scale. You know, how best to operate your facilities is probably one of the issues that you principally address. But I don't think there's a blanket answer to that. So I would say I think we need to be able to address questions at the watershed scale, and sometimes there are administrative hurdles to surmount in order to do that. But otherwise, I don't know that there's a specific scale that's exactly right.
Okay, let's go on to our next question, unless Louise or Stephanie have something you want to add there. So Steve Brand asked a question on the chat. There was a lot of discussion about mechanisms, modeling of communities. Is anyone working on developing a comprehensive food web model?
I can start off real quick on that. I think it's a great question, and I think there has been work, I believe, under Larry Brown in the past at USGS. I don't know the status of that. But I will say that I didn't get to mention this in my comments, but I did talk about the collaboration with NCs that we are trying to get underway in 2021. And the topic of that will be drivers of the estuarine's food supply, in which we hope to take a stab at developing a broad suite of species distribution models that would then inform how you would go about modeling communities of food webs.
Okay, thank you, Louise. Anything else anyone else wants to add? Or
I think I might just want to add that IEP's definitely had some support in that effort. We've had a lot of conceptual models that have come out in the past that would probably help develop quantitative models, but not quite there yet. So I'm definitely looking forward to the NC's effort that Louise and the science program staff are going to be leading.
Great. And I think I saw Bruce DeGennaro had raised his hand. Bruce, you can unmute yourself if you have a question.
Yeah, great. Thanks. Great comments from everybody. Really appreciate that. Because my question, and this isn't an easy one, I'm never going to give you a softball, but the changes to the ecosystem are so rapid, and with climate change kind of, seems to be increasing even faster. I just wonder, how do we get ahead of it and be proactive instead of just reacting? It takes us a while to see the change, and then what do we do about it? It just seems like by the time we figure it out, it's the next invasive species on us. How do we get ahead of it? I guess that's my question. Or maybe how can research help us get ahead of it? Maybe that's more pointed.
I am happy to jump in unless Stephanie or Mike, you want to. Okay, I appreciate the question, Bruce, and it is, you're right, not an easy one. Well, one of the reasons that I wanted to highlight the need for really advanced and a focus on data science is that I think that we need to become faster and actually use automated techniques that are built into our platforms for visualizing data. And I think we need to develop a habit of having a suite of data sets that are showing us trends, and that we have a habit of actually looking at those, even if we don't have a specific management question, but that we are looking at trends in turbidity, trends in the phytoplankton community, trends in temperature. I think we need to have more effort go into status and trends and a practice within our community of looking at those. And I again want to highlight the work within CAMT that we are trying to lead with we developed a kind of a Delta smelt conditions report, and also within IEP led by Rosemary Hartman, the status and trends report, which takes long-term data and develops a visualization of it. but we really need to make that more accessible and be promoting it more. So the first thing to being able to respond is to know what's going on in the first place. We just need to be in the habit of looking at our data, even when we don't know what we're looking for, because we won't know what all the changes are. That's just part of it, but I think a critical fundamental piece.
Stephanie or Mike, you have any additional thoughts?
I absolutely agree with what Louise just said, but I wanted to add something. One of the jillion things that I've learned from Larry Brown is that when you talk about climate change, you know, the things that people were looking at just a handful of years ago and thought would never be the case. You know, that's so far down the road. That's not a likely scenario. It's the scenario that we have now already. And so not just looking at our status and trends, but also looking at those extreme cases, because soon enough, they're not going to be extreme. And so if we can proactively look into some of those sorts of situations, we might be a little bit better poised to actually address them when they get here.
Yeah, and the only thing I would add, because I completely agree, is that you know, it's hard to get ahead of things sometimes when especially when they're complicated and they're contentious, which climate change certainly will be, and its implications certainly will be going forward. So I think, you know, and maybe I'm just underscoring something Louise said. One of the things that we should be trying to do in order to manage the issue going forward is to figure out ways for us to, again, to cut through the level of detail in a lot of the data and you know, help people draw appropriately well-justified inferences from the data that are available. Because I think there are things that we can do to streamline the process of interrogating the scientific record as these things come up, and we should be working on those.
I have one quick thing to add, really quick. I just wanted to say, Bruce, I think the Collaborative Science Adaptive Management Program and the CAMPT team it's important to have that practice and habit of status and trends examination, but also the group to do it with. And so those collaborative venues that you so expertly facilitate are also a really key piece of this very question, that we make space to talk about what we're seeing. And especially important now as we all work remotely, we need to be talking to each other. And I think that speaks to some of the major points that Mike made of we need to work more together. So that just wanted to emphasize that.
Yeah, and if I can add one more thing to that, I think that as Mike was saying and Louise was agreeing with, the teams that we have to put these discussion pieces together are very important. We need to not only think about multiple interests, but also the multiple backgrounds and expertise that come into the discussion. We can't just have hydrologists and biologists anymore. We need a full suite of different ologists to really get at the questions, and being able to do that together in a way that we have more comfort in the end result is really what I think we're looking for.
Great. Okay, we have a few more questions. So online, we had a question from Anthony Navasaro at the Stewardship Council. He wanted you to expand on the reallocation of resources. If we aren't going to increase resources, how would we go about doing that reallocation from what program or what study to what, or using what sort of information to prioritize those? Any thoughts? Mike, you talked about that if you want to add.
Yeah, and I sort of feel like any specific answer to this question invites getting beaten over the head by people.
Any thoughts on how we can do it?
I won't chicken out exactly, but I will say this is why I think we have to make these decisions as a team, because it's inevitable when you reallocate resources that somebody's ox is going to get gored. And we need to be able to talk to one another so we can make rational decisions, because I don't think we necessarily are on the wrong track at present. I think most of what I'm thinking about are refinements to what we're doing, but I think they do require a group dialogue to make any specific choices.
Okay. Anything else, Stephanie or Louise, you want to add, or we could move on to a new question? Or
Just real quick, I think this is where the collaboration that Mike mentioned is really important. And I think that the collaborative documents, not to be too self-promoting, but I can't help it a little bit, the development of our science action agenda, where we are trying to ground the new science action agenda and identify science priorities based on management questions, is a collaborative effort that draws on outreach that we are doing throughout the community and can help with this question of identifying where we need to put resources that we have.
Great.
And if I could just put a spin on the question other than the collaboration, I think that one thing that we're finding in our long-term monitoring review effort is that we're starting to be able to quantify the little pieces that in the past were always sort of attributed to expert knowledge. And we're actually finding that when you look at things, looking at the data and what the data can tell you, it's oftentimes telling us what we kind of already knew but didn't know why. Not to say that we were always right, but just that these advanced amount of effort put to Y and Z, that we should get this expected outcome that would be more beneficial than if we did something else.
Great. Thank you, Stephanie. Okay, I see Rachel Wigington raised your hand. Rachel, can you unmute yourself and welcome your question? We have just about a few minutes left, so if we could keep the question and the answers relatively brief, we may be able to squeeze in one more question.
Okay, great. I feel like this one might be a little bit shorter because I feel like some of it was spoken to, but earlier, Louise, you were discussing the status and trends report that Rosemary's been working on, and you said making those sorts of things more accessible would be a good next step. And I'm sort of curious what exactly you mean by that. Like, how can we make these tools more accessible?
Well, thanks for your question, Rachel. I will be brief. I think you know, and many of us know, that there's been challenges to accessibility of materials online. And recently, as we move towards more stringent compliance standards, and we need to meet those standards, and we need to have all of our reports, such as the status and trends report, available online.
Okay, so we have one last question quickly from Mark Lubell. He asked, is there currently any effort to catalog the range of long-term data sets that exist in the Delta Science Enterprise and to develop some type of relational model to see where these data sets connect? Any thoughts?
The first thing that comes to mind is the Delta Independent Science Board's Monitoring Enterprise Review. And John, I'm guessing you could answer this question better than me, but I think that speaks to exactly the question, which is a great one. That is looking at over 150 long-term data sets in the Delta system, and is actually looking at how these are related to each other. So more to come on that as that effort moves towards completion in the next year or so.
Yeah. Okay, well, I think it's 10:14, so we have just 1 minute left. We're pretty much out of time. I thank you to the panelists for your really thoughtful discussion and insight, to everyone for participating. We really appreciate this discussion, and we will be taking input on, we took a lot of notes on all of your input, and we will be incorporating that into the October workshop. As a reminder, we have scheduled one more discussion, that's September 9th, and that will focus more on governance and organizational issues. So I encourage you to tune in on September 9th. And then if you have any additional comments, please don't hesitate to reach out, emailing Amanda Bohl, who is the coordinator at the council who's leading this effort, and her email is amanda.bohl@deltacouncil.ca.gov. Or you could also use that disb@deltacouncil.ca.gov. So thanks again for all of your input, and thank you to the panel members again. So really valuable discussion, and enjoy the rest of your day. And Edmund, is there anything you'd like to add?
No, I think you covered it. Thanks, John.
Okay, great. Thank you all.
Thanks, everyone. Thanks.